Hello and welcome to another malware forensic analysis video. Apologise now, I've picked up a bit of a cough, but I'll try and keep coughing down to a minimum. Today we're going to be taking a look at a piece of metamorphic malware called Lexotan32. Again, it's not a particularly new piece of malware. In fact, it's wrote directly in assembly, and it's was coded to be compiled using quite an old compiler. So it's nothing new, but the techniques that it uses again are really quite clever techniques. So just as a bit of background, so before we've done videos on polymorphic viruses, and that's basically been the malicious payload is encrypted and it's packaged with a stub that morphs to decrypt that payload. Sometimes the fact it's got an encrypted payload is enough to trigger off some antivirus software. So a metamorphic virus doesn't use any encryption at all. So basically the entire payload is completely morphed, and it uses a metamorphic engine to extract clean code from that to then execute. The one we're having a look called Lexotan, I really like because it almost mimics biology in the way that it extracts the virus. So it uses a genome to basically extract the clean code out of the metamorphic code, and it then in that payload has the metamorphic engine. So on reinfection, it generates a new genome, generates a new morphed software to go with that, and then it basically packages the genome with it. But it's really quite clever the way that it works. To watch this when it executes in a hex editor is really quite fascinating. So I've got the code for Lexotan on my GitHub. So since we've actually got the code for it, we're in a great position where we can compile the first generation of this virus and watch it execute. So if you go onto somewhere like VirusShare or some sort of online virus repository and download a copy of a metamorphic virus, it could be bloated in size. So something like Win32 Evil, it was a metamorphic virus, but as it morphed, it didn't used to shrink or compress the code down, and it just used to get bigger. And for somebody to then have a look at in like a hex editor or in another tool, it was quite a lot to try and digest at the same time. So this video is focused around compiling a first generation version of this virus. During that, we kind of get in the mindset a little bit of the virus writer, which is pretty cool. So let's crack on. Let's have a look at this. The actual malware itself, the code base for the malware itself was released on Virus Exchange. So these are a lot of the viruses wrote by the author called Vecna, and Vecna released a copy of Lexotan on here. So there's an older version of this virus called Lexotan, and there's a newer version called Lexotan32, and it's Lexotan32 that we're really interested in. So you can kind of tell as you look at different source codes for this malware writer how their skills have evolved over time, and you can see a huge jump between what they wrote with Lexotan and what they wrote with Lexotan32. So let's have a quick look at those code bases. So I've got them here. So this is the 1998 version that Vecna wrote called Lexotan. It's got a very small number of files in here. You just really got one that you've got to worry about in assembly. It's pretty long. It's pretty straightforward to read through, and it's very straightforward to compile. You just need Borland Turbo Assembler version 2 to compile this. In contrast, the Lexotan32 version that you can download from Virus Exchange is a lot bigger in size. So it's got loads more stuff that it includes. It's now got a make file, so it's got to run through a load of pre-processes before it can build. The actual assembly itself, so it's in virus.asm, it looks a lot shorter in here. However, it's including a hell of a lot more high-level language files now. So it needs these preprocessors to kind of flatten this down into a file before Ball and Turbo Assembler can even compile this now. It's got a load of these macros declared. So this free for garble function, we'll have a look in a future video at exactly what this does, and we'll run this in we'll run this and have a look at it in a hex editor. But for now, we're just going to see if we can get this compiled. So this version of the code that you see, there's some files in lowercase. Well, these are the files that were missing. And so when I first downloaded this, tried to compile it, it wouldn't work at all. These files I had to try and hunt down either from other samples that Vecna had wrote, or from other virus writers within the virus writing group that Vecna was part of. So Vecna was part of a prolific virus and hacking group called 29A back in the day. So 29A being being quite prevalent in the virus writing scene back then, but in recent years have kind of have died off as far as what they're working on and what they've exposed. In fact, I think it's even disbanded now. So I got to a certain point with this where there was still stuff missing. So in this make file, excuse me, the biggest thing that was missing was this preprocessor. It's the first step in this make file is run this preprocessor that takes these files and flattens them into this virus.a, and then the next level basically then takes Turbo Assembler and starts to compile that. But I couldn't even get past this stage because half of these files were missing, and even trying to shove in like this main.asi, this file didn't quite work the way, and I wasn't really happy that it was I was actually kind of making the same virus at the end. So I did some research and I found that there was this guy who wrote a paper on Lexotan32 called Orr, who actually got it compiling, and I contacted him and was basically asking how he got the code running, and he said that the code base on Virus Exchange was incomplete, and that you need to go to Vecna's website to get the actual full version of the code. Vecna's website by now was taken down, no longer online, so I couldn't really get hold of that paper. So I couldn't get hold of that code base. So Orr kindly put me in the direction of a copy that he had. So I've taken that copy, and that's the exact copy that I've put on GitHub. So I've got a copy on GitHub. I'll probably end up patching this after this video. I mean, you'll see why as we go through it, but it still doesn't compile. But let's get going and actually start compiling it. So if I clone that down first. Okay, so we've got that clone down now. So we don't have to worry about this version of the code base. Let's worry about the other one. So immediately we've got the preprocessor now, which is awesome. We can get past this first stage. We've all of those functions that I was saying before that I mucked around with, they're all in uppercase. That it's a good indicator that this is all in one piece. So I think we're in a good position where we can we open up the make file for this in this repo. We can actually start kicking off with this. So let's do that. What I've already done prior to this video, I've downloaded Ball and Turbo Assembler from WinWorld. So this place is great. It's got a library that's full of old versions of discontinued operating systems, discontinued utilities. So under development tools, there should be a with Borland in here. So we've got Borland Turbo Assembler. I downloaded version 5 from in here. It's a bit out of to your VM. You could always rebuild these as an ISO if you really wanted to. I'll put all of these links in the show notes. So that's all installed. I've added it to my path. So when I go into the command prompt, make will come up with Borland's turbo assembler's make command. So let's go into Lexotan and let's run that make file and just see what it does. Okay, so immediately preproc .exe fails with a runtime error of 200. Already hunted this error down. So it's basically this file would have been originally compiled with this crt.asm back in the day, and this had a bug in it that didn't manifest itself until machines were faster than 200 megahertz. So what'll happen is the machine will just run too quick and it'll get divided by zero exception. So Vecna must either run an old development machine that they're very attached to, or they've got a workaround for this and they've basically been using the preprocessor for a very long time and they just don't want to change it, don't want to patch it. So I've already downloaded this fix file and that should be on my desktop. And there we go. So let's copy this and we'll copy this into we'll copy this to my to that where that code base is. We'll just dump it straight in there. So already we're starting to get into the mindset of the virus writer now. You know, we're seeing the type of tools that they're using. We're seeing their attachment to some of these older tools that they've built over time, such as the preprocessor. You know, they're tried and tested with them. They work, therefore they keep using them. Okay, so we're still getting that, but that's because we need to run that. We need to run that fix first. Okay, so that should allow us to run the make file and get past. Okay, yeah. So the preprocessor's run. It should have created a virus.a file, which it has. It's created a virus.object file as well, which is good. So it's finished this stage. It's finished this stage, so it's run turbo assembler. And it's run the T-Link, which is great, and then it's died because it can't find this PureSec file, and that's one of the final stages here. So what is this? You know, got no idea what this is. Searching for this on the internet, couldn't find any sign of it. So again, it must be a custom tool that's used by Vecna. I couldn't find it in any of Vecna's old code bases. So then I started to dig into what this 29A group put on the internet, and they've been really quite open with what they're working on. So they created these newsletters, which was just great to read. So they're usually in the format of they've got articles, they've got binaries, and they've got binaries that have been released by the different individuals. So I had a look for Vecna's ones to see if I could find any of these missing tools. They've got utilities. They've also got copies of viruses that they've released. So it's really good. Just reading through this was awesome to get in the mindset of how these guys work, how these guys collaborate, seeing some of different developers' tools being used by other developers, and being able to see the close collaboration between certain individuals was quite interesting. So the basic process was to go through each of these newsletters, have a look at the files, and see if I could find any of the extra files that I needed. So this one here, straight away we've got the PureSec files, so I'm just going to copy that directly into my Lexotan source, and I should be able to run make, and we've got an exe file. So that's pretty cool. So let's load that into IDA. By the way, that PureSec file just sets some sort of flag on the file for a first generation version of it. I won't go into too much detail about why. I mean, honestly, if you want to have a look at what and why some of those functions work, then go and have a look at those 2019 newsletters, because they're just awesome to look at. So let's have a quick look at that first generation copy, which is here. So it loads brilliantly. It looks uber complex, but we've now got a first generation version of this that we can trace through and we can have a look at if we want to. So in the next video in this particular series, we'll have a look at some of the techniques, run this in a hex editor, and we'll have a look. So thank you very much for watching. Again, apologies about the cough. If you enjoyed this this video, or you've got any comments about it, then please place them below. You know, as I say, feel free to put any comments below. If you like this or you want more like it, then please like or subscribe, and I'll hopefully have got rid of this cough by the next video. Thank you for watching.